Hey guys, so this is actually my second attempt trying to do this video because I saw the group chat was blowing up for food. So let's hope for a good run here. So let's get started with the first problem. Let me just pull up. Okay. So we're going to start off with the mass of a sample is 550 milligrams. Which of the following expresses that mass in kilograms? So we want to go from milligrams to kilograms. So let's start with 550. We could say mg. I find that ugly. Times our first conversion factor, which will be, we first have to set the bottom equal to milligrams, and on top we're going to go grams. So it might be possible to go straight from milligrams to kilograms, but I would just from milligrams go to grams and then go to kilograms. So if you guys watched my video, I talked about how these prefixes matter. So if it has a prefix here, the milli, I'm going to put a 1. If it doesn't, like here, and it just has the grams, I'm going to put the 10 to the number factor. For milli, it says 10 to the negative third. You know that big chart that has like 10 to the negative third, or maybe it has 10 to the second, 10 to the third, maybe 10 to the sixth, 10 to the negative 6, those numbers. This is where I'm getting the milligrams conversion from. Now they want it into kilograms, so currently right now we're going to be in grams. So let's do another one. Grams is going to be on the bottom, kilograms is going to be on the top. I'm going to put 1 up there because it has a prefix of kilograms. Grams, we're going to put the 10 to the number, which for kilograms is going to be 10 to the third. Now let's cross out our units. Now we're left with just kilograms, and if you solve this, you're going to get and our units are going to be kilograms. So our answer is going to be 5.5 times 10 to the negative 4 kilograms. Our next one is determine the number of centimeters squared in 1 inch squared. I also went over this question in one of my videos about talking about what happens if you have a number like this in squared or something. I showed you an example of it cubed, but it's telling us we're going to start with 1 inch squared. So 1 . So we know that we at least have to put inches on the bottom, and we have to figure out, well, we can't use the 10 to the number because we're not in the empirical system. I believe we're in, or one of the systems. We're in, you know what? Let me double check. I think we might be in the, is this the imperial? We're in the US system, so we can't use 10 to the something. If we look at our reference table, or I believe it's just called the conversion factors, we're going to see that 1 inch is equal to 2.54 centimeters. So 1 inch, 2.54 centimeters. But they're looking for it in centimeters squared. So if you watched my video, you already know what I'm going to do. We're going to square here. Now it's not just going to square here. Oop. Not just going to square there. It's also going to square here. So all these things are going to be squared, leading to, you could think, yeah, you know what? Yeah, let's do it like that. Leading to Why can't? Okay. 6. If I just attempt it again onto my calculator, we'll do 1 times parentheses. I did parentheses for everything. We're going to get 6.4516 something in the calculator, which equals to right there. Bam, easy. Now, a large pizza has a diameter of 15 inches. Express this diameter in centimeters. Another nice question. So now we don't have to think about the squares. So we just learned about a conversion factor with inches on the bottom, centimeters on the top. 1 inch is going to be equal to 2.54 centimeters. And they're asking for centimeters. So let's solve this. It's equal to, let me put this into my calculator. We get 38.1. Is there anything close to that? We get choice C. Let's try the next one. At a pressure of 1 billionth, 10 to the negative 9, of atmospheric pressure. This actually is, you might have seen it, I don't know, I think ATM. But let's continue. There are 2.7 times 10 to the 10th molecules in 1 cubic centimeter of a gas. How many molecules is this per cubic meter? Whoa, we have a lot going on right now. So, they tell us something about pressures, billionth. This one, when I first read it, I was like, hold on, something's a little bit off. Let me reread it here. What we want to start off with is actually the 2.7 times 10 to the 10th molecules. So, follow me here. So they're giving us something in molecules, and they're also telling us that it's actually over 1 cubic centimeter. And they're telling us to put this molecules in cubic meters. So they're telling us, let's keep the molecules on the top, but on the bottom we want to switch it out for cubic meters. So it's another conversion. Prefix, no prefix. We're going to put a number 1 here. We're going to put 10 to the 10 to the negative second. I'm just going to double check. Okay, so we're going to put 10 to the negative second, which I was right. I just needed to double check, guys. But now we want to actually cube this. So if we decide to cube the top, it's going to be the same thing here, same thing here. Now we're actually going to multiply this one by 3. So if we wanted to completely rewrite this, no. Okay, good. If we wanted to completely rewrite this, we could say 1 cubic meter is equal to 10 to the negative 6th cubic meters, which is going to be equal to answer of 2.7 times 10 to the 16th cubic meters, which is equal to C. Let's keep rolling. A 14-karat gold ring contains 58.3 gold and weighs 12.41 grams. If gold sells for 308.0 per ounce, what is the value of the gold in the ring? So, I'm not sure if you guys have gotten one of these questions, but the way you want to start is you want to figure out how much gold or the total weight of gold is in that 12.41, because this is the total of a 14 gold ring. This is not total. It's not. So let's change this into a number that we're going to multiply by the total weight of the ring to figure out how much is that gold. We get a number of 7.23503 grams. We get some big number there. Times, and I wasn't going to worry about sig figs for this one just because it doesn't look like there's a number here that really is about sig figs, so we're going to put, oh, I might have went too fast. So now we need to figure out, we need to go from grams to something. So let's look at a conversion factor where we see 1 pound is equal to 453.59237 grams. So 1 pound on the top, 453.5923027. But wait, we're not supposed to be in pounds. We would be in pounds there. Let's get to ounces. I am going over the answers. You know what? Let me stretch it all the way over here. So we need to be pounds on the bottom to cross them out, and something on the top. Let's look back to that conversion factor table. We see 1 pound is equal to 16 ounces. So ounces. This will give us a number of, oh god, I have, where do I want to put this? I guess I will put this right here. So if you solve for that number, you will get 0.255208. We're actually going to multiply by 308 to figure out how much the amount of gold will sell. It's 308, right? 308. Now we get, oh god, this is a bad placement to put this. $78.60, which is answer choice E. That squeak was my chair. That was my chair. Still, I have this very squeaky chair. So let's figure this one out. This is about solving this and following the correct number of sig figs. So if I see here, we have 1, 2, 3, 4, 5 on the beginning, 3, and 3. So let's solve for the first one. We're going to get 79.1 because for the first one we want to keep it to 3 sig figs. On the bottom, we can have 4.2 times 1.4097. We're going to keep it to 2 sig figs this time. But now we're seeing, division. What's the rule for division? It's the same as multiplication, which is going to be lowest number of sig figs. So this one's going to have 2. This one's going to have 3. So we have to have our final answer as 2 sig figs. And I think it's 13 you would have in your calculator. You know what? Let me solve it. 39. You would have like 13.40677, but they want it in 2 sig figs. So what we're gonna do is that. We're done. Which of the following correctly expresses 0.000007913 grams in scientific notation. So scientific notation is going to be those like 10 something times 10 to the 60. I don't know. It's going to be one of those, which is what we have here. And they're all back at 7.9. So let's get back to 7.9. We got 1, 2, 3, 4. Hold on. Let me recount. 1, 2, 3, 4, 5, 6. So it should be 6 something. 7.9. What do they keep it? Okay, they keep it as like that. And for this one, we went 6. This will be the correct answer here. Because if we looked at this, and if you wanted to see, okay, is it going to be positive or negative? Let's look at these answer choices. If you were given this one here, and you said 10 to the 6th, that means your decimal would go this way. 1, 2, 3, 4, 5, 6, 7, 6. Ignore the 7. It would create it would get a bigger number. This one means we would get a smaller number than 7.9. So our answer choice is going to be A. Great work, great work. Halfway. About halfway. Calcium fluoride. So this one you need to, you don't actually for this one. They give you it. So calcium fluoride, it's asking for the molar mass, which is just going to be you could say total grams for now. So calcium is going to equal 40. Or you could say, yeah, total mass. Now we have fluorine here. Right now, all I'm doing is using the periodic table. And now we have 2 fluorines, so we have to remember to eventually have 2 of the 18s. And in total, this is going to equal 78.07 grams per mole, which is, bam, another simple question. Magnesium fluoride. They don't actually give you the formula for this one, so let's figure out magnesium fluoride. So magnesium is going to be Mg, and if I get my periodic table, it's going to be group 2, so we're going to remember plus 2. Fluoride, we have to remember that it is F minus. You could keep it like that, or you could put a 1, but I'll just keep it like negative because it's on the, what is it called, the polyatomics. So we need 2 fluorines in this section to balance out the magnesium. So we're going to make this. Bam. And now what they ask us is, what is the mass of 1.72 moles of magnesium fluoride? So let's first start off with 1.72 moles. They ask us for the mass of this amount of moles. So it's good that we calculated the molar mass because we need to cancel out moles on the bottom. And if we use the molar mass, we'll know that 1 mole is equal to the molar mass. So grams on the top. We figured out, we didn't figure it out yet. Here, let's do it right now. Magnesium is 24.305 plus the fluorine. Remember, I want to say it's like, I'll put that there. So now we are going to have an answer of 107.15, anything close to that. I remember we have choice answer C. A weatherman incorrectly stated that the temperature was 85 degrees Fahrenheit, 35 degrees Celsius. Oh, okay, so he said it was 85 degrees Fahrenheit or 35 degrees Celsius. If the Fahrenheit temperature was correct, so they're saying that this number was good. How far off was the Celsius temperature? Okay, that's fine. So, let's try to get our Fahrenheit into Celsius, which will be this formula here. We will include the 85 here. You could write it out like that. That is no issue. This will get you let me not do that. It should be equal to 29 point, let me recount. I think it's 29.4. 29.4. So now what we want to do is that we have this number now in Celsius. Let's subtract it by the number that he puts in Celsius. Let's see, so we get 35. We get 5.6. There's not a number that is 5.6, but the closest one will be 6 degrees Celsius, which will be our answer. Calculate the number of moles in 17.8 grams of antacid magnesium hydroxide. Hold on. I had to crack my neck because I did. So they give us 17.8. And they want us to get into moles. So mole. And the one conversion that we can use is the molar mass. So let's figure that out. Magnesium, they give us it right there. Magnesium is going to be 24.305. Oxygen is going to be 18.998. No, not 18.998. No, not even that. 15.998. Please tell me I didn't make that mistake. I didn't make that mistake anywhere else here, right? No. Hope not. It's 15.998. Hydrogen is going to equal 1.00. And I think on your periodic table it says 0.79 or something. 0.79. I usually use 1.008. I think at least for my reference table it showed that. Let's calculate this. So we're gonna have 24.305 plus, and we want to have 2 of each because we're multiplying the hydroxide by 2. So we're gonna have that 15.998 times so we should get a number around, oh, where did this go? 58.3168, which we will plug right back into our equation. No, it's, yes. And since it's our molar mass, we're going to know that it's equal to 1 mole, which is going to equal, let me write it over here, which is going to equal let me just double check that with my own calculator. 0.305, perfectly done. We are rolling through this, guys. Which of the following samples has the most moles of the compound? So let's start off. This was one of the questions that, oh my god, my chair's squeaky, and incoming a noise from my printer because I printed out a periodic table. Really? So the first step is that, let me write this smaller here. They give us something in grams. They want to figure out which one has the most moles. So all we have to actually do for this one is divide by the molar mass, because we're going to get moles on the top and grams on the bottom. So I'm just going to give the molar masses for these. If you guys want to try them out and double check my work, that is fine. And I'm going to just show you. I'm just going to try. Okay, so we have 1.337 moles. This one is 50 grams. And I'm just going to give the molar mass for all these. This one is 50 also. Oh, whoops. So it's looking like maybe B is the answer. So still nothing has beaten B. Maybe the final one. So it looks like B will be the right answer. Sulfur trioxide can react with atmospheric water vapor to form sulfuric acid that falls as acid rain. Calculate the mass in grams of 3.65 times 10 to the 20th molecules of SO3. So let's quickly get through this. 3.65 times 10 to the 20 molecules. We need to get through this fast so that I can turn on my fan, because it's actually a little bit hot in here. So we're going to divide by molecules because we want to get out of molecules and into grams. Think into grams. So we can't be in moles, so let's use the molar mass to get right out of moles. The molar mass for this sulfuric acid will be 80.059 grams. We're going to get an answer of somewhere around 0.0485, which if we try this, we'll get 1, 2, so we'll get up there, and that looks to be it. 2 more, guys. 3 more, I meant. Lead 2 nitrate is a poisonous substance which has been used in the manufacture of special explosives as a sensitizer in photography. Calculate the mass of lead in 139 grams of PbNO3, and there's going to be 2 of those. So, how do I want to do this? So they want to calculate the mass of lead in this specific 139. So let's calculate this. This I found to be 342.2838, you can say. And, oh, I looked at the wrong one. Whoops. Sorry, guys. 331.202. And what we want to do with that, since we want to find out the mass of lead in that amount, we want to do is we want to find out the percent of PB. So I'm going to use this formula of the mass of the element over the mass of the compound, or the substance you could call it. I could multiply by 100, but eventually, you're going to see why. I'm going to multiply my number here, which I get to be 62.6254, which is, if I multiplied by 100, it would be the percent of lead in the entire substance there. But they want it, they want it in 139 grams. So we want to multiply by 139 to figure out how much mass of lead is in the 139 of our substance. We will get 86.96 grams, which will equal 86.9. It's going to round up to B. Sorry, I stumbled a bit there. I was just looking at something else. They give us the molecular formula of sucrose. What is the percent of carbon in sucrose? So same thing, but now they just want the percent. So 12.011 times 12 is around 1. We're also going to go over the total mass of our substance, which is going to be, not that, 2838. We are going to multiply by 100 because they want a percent now, which is going to be, not that, 40. I thought that was 9, but no, it's going to be 42.1%. Bam. Last one, and it's the easiest one, which I don't know because I didn't actually look at this one. So the number of hydrogen atoms in 0.050 moles of C3H8O3. So they give us something in moles. Let's at least write that down. They want hydrogen atoms, so we know we have to get out of moles, 1 mole, and we're going to actually go to molecules here, not like that. We're going to use Avogadro's number, go straight to molecules. Then, how we've been doing it, we are going to take, since we want hydrogen atoms, we're going to multiply by 8 atoms of hydrogen over 1 molecule of C3H8O3. Does everything cross out? 1, 1, 1, 1. We're only left in atoms. When we solve this, we get A is our answer. Alright guys, remember you need to figure out what is it, balancing I have a couple of balancing if I could hopefully find them. Let me see if I could find them. Did a couple here if you want to take a screenshot and I guess figure them out. Thank you guys and good luck studying. Lock in. Everyone, I just realized that I did not go over 13 and 14 for some reason. I had to step out for a second, but I'm back. You thought it ended. No. So, calculate the number of oxygen atoms in 29.34 grams of sodium sulfate. So we're lucky enough to get the whole compound there. So let's start with our 29.34 grams of sodium sulfate. So we want to get to atoms, so we want to get out of grams, and the only way we're going to get out of grams is if we go to moles from our molar mass. Remember, the molar mass is going to be the total mass of this substance, which I calculated as 142.037 grams. If you want, you can calculate that and double check me. It's going to be 2 sodiums, 1 sulfur, 4 oxygens. So we're going to multiply that. We want to get moles on the bottom. And for this one, if you remember, this was one of those, trick question that Professor Lacey put up. We're going to put molecules on the top. We want to figure out the number of oxygen atoms. So how we're going to do this is we're going to get into molecules. Hopefully you guys can't hear that notification of my GChat. I don't know. So we're going to get 4 atoms of oxygen. We're going to put that over 1 molecule of Na2SO4. Once you solve for this, you will get I don't know how to turn off that notification, at least on my MacBook. I gotta do this question fast because I really don't know if it's gonna pop up, but that is our answer for this. Now we're gonna go to number 14. So we're given grams, and we want to get the number we want to figure out which one has the most number of atoms. So the way you want to do this is, as the professor showed us in one of those trick questions, was that you start off here, and let's first get out of grams. This is going to be the molar mass. And we want to go right into molecules. Now this one has 3, so it's Li2 and 1 oxygen, so we're going to have 3 atoms. Now I'm not going to show you all of these, I'm just going to show you 2 more. Just because it's a lot of just the same thing. I'm hoping it's 5.9, or it might be 5.4. My handwriting is really bad. But if it's 5.4, you guys will correct me. Put it over Avogadro's number so that we can get into molecules, so that we can get out of molecules, because this one has 4. So this number should equal now we still have not actually reached the right answer, which is going to be D, and I'm going to show you why. So 200 grams. Let's get out of grams by using the molar mass, which is going to be 159.68. I can't read my handwriting. Okay, guys, it's either going to be 4 or 9. I think it's 4. I'm looking at the the notes that I wrote down for this video. So five atoms, because this is, I think, Fe something, Fe2O3. We're gonna get this as our final answer, which means D is the right answer. I'm not gonna show you them all just because it's a lot of work. So thank you guys for watching, and enjoy a, what should I draw? I'll try to draw I'll just do my regular. Beep, beep. You know what? Beep, 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 beep. Here. Me. Good luck studying, guys, okay? Hey.